Right, what we have in front of us is the most famous quadratic formula. If ax squared plus bx plus c equals 0, a not equal to 0, then x equals 2c divided by minus b plus or minus the square root of b squared minus 4ac. This is the quadratic formula. Okay, let's proceed to prove this quadratic formula in a step-by-step fashion. We proceed most certainly as follows. Right, so to prove this here, we proceed as follows. Right, what do we have here? Right, first things first, we have ax squared plus bx plus c equals 0. A not equal to 0. Right, so with this said, what do we do here at this point? We decide to divide by x squared, both each of the terms, getting a plus bx. So you can write like ax squared over x squared. Okay, like that. You can write to make it easier to understand. Bx you divide by x squared plus c you also divide by x squared. The result is 0, you divide by x squared, etc. Okay, right. Now, what do we get? So obviously, the understanding is that x is not 0 here. Right, and this gives us exactly a plus b over x plus c over x squared equals 0. All right, upon further examination, we divide through by c, getting a over c plus bcx plus 1 over x squared, like this. And that's exactly what we get at this point. Right, if you look at this very carefully, what does this yield? So this yields 1 over x squared plus b over cx plus a over c equals 0. And then now upon further examination, we're able to complete the square. And if we complete the square, we have this plus b over cx plus, right, we have half of the coefficient of this expression. And therefore, we should have exactly b over twice c. We square this minus b over twice c. We square this, and we also have a over c equals 0. And this is 1 over x plus b over twice c. Like so, we square this minus a over c minus, okay, so this is going to be plus, because if you transpose this term here, it's going to be plus on the right, b squared over 4c squared, like so. And what is this? So this is exactly 1 over x plus b over twice c. You square this, and this is exactly the same as what? It's exactly the same as, right. So if you take 4c squared as the denominator here, we have 4c squared divided by c, which is 4c by a, is becomes minus 4ac plus. So 4c squared divided by 4c squared is 1 by b squared. It gives us exactly this. So what we are getting here exactly is what? What do we get here precisely? So what we're able to achieve here is that 1 over x plus b over 2c squared is equal to the same as b squared minus 4ac all over twice a. All right. And we then proceed from here. Oh, all over 4c squared, excuse, like this. And this means that 1 over x plus b over 2c is plus or minus the square root of b squared minus 4ac all over 4c squared. 1 over x plus b over 2c is equal to plus or minus the square root b squared minus 4ac all over 2c. Okay, this is the result. And what is the meaning of this? So what we're getting here is that 1 over x is actually equal to minus b over twice c plus or minus the square root of b squared minus 4ac all over 2c, like so. Okay? And now this means 1 over x is the same as what? Minus b plus or minus the square root of b squared minus 4ac, like this, all over twice c. But if you reciprocate, taking the reciprocal, both sides of this equation, we're able to achieve that x is the same as twice c, all divided by minus b plus or minus the square root of b squared minus 4ac, like so. And now, with that said, then this is our quadratic formula. This becomes exactly our quadratic formula. Right, hence, if ax squared plus bx plus c equals 0, then x equals 2c divided by minus b plus or minus the square root of b squared minus 4ac, like this. Obviously, here we sort of have the understanding that this is a quadratic if a is not 0. So we sort of have that assumption. Right, so with that said, then we need an example to prove this, or to sort of verify that this formula is correct. So let's look at an example. Right, so an example is extremely important for us to sort of verify that this works. Right, how do we prove this then? Right, so to sort of verify that this formula works, we proceed as follows. Solve for x. Solve for x. Right, given 3x squared plus 11x plus 8 equals 0. Okay, first things first, we're going to use the standard procedure. And using the standard procedure, we will present the solution to this problem. How do you present a solution to this? So the solution to this is going to be as follows. if you have 3x squared plus 11x plus 8 equals 0, you multiply 3x squared by 8, we get 24x squared, which means if we have 24x squared, we will consider two numbers whose product is 24x squared, or two expressions whose product is 24x squared, but whose sum is 11x, which is exactly 3x plus 8x plus 8 equals 0. Right. Upon further examination, you can factor out. So you can write like either like these, or you can say, for example, this is exactly 3x squared plus 8x plus 3x plus 8 equals 0. So you sort of have this sort of symmetry in the way this works. So just to note the symmetry here. Okay, right. 3x being a common factor, and you have x plus 1. Pull out 8, and we have x plus 1. Meaning we have x plus 1 here, and you have 3x plus 8. And this means x is minus 1, or x is minus 8 out of 3, like so. And we do the same here. Okay, here you can pull out the common factor being x, and you have 3x plus 8. And here you have 3x plus 8 equals 0. Having 3x plus 8, we have exactly x plus 1 equals 0, which means x is minus 8 out of 3, or x is minus 1. Okay, so these are the solutions to the quadratic equation 3x squared plus 11x plus 8. But let's use that formula to verify that these solutions will be obtained using the suggested quadratic formula. So now we are given here. We are given 3x squared with 11x with 8. On this is 0. Okay, in comparison with ax squared plus bx plus c equals 0, a not 0, it means a couple of things, but it suggests that a is 3, b is 11, and c is 8. So that we have said that the quadratic formula here is x equals twice c divided by minus b plus or minus the square root of b squared minus 4ac, like so, which is twice c, which is twice 8, divided by minus b plus or minus the square root of b squared, which is 11 squared, minus 4a, which is 3, c, which is exactly 8, like so. And then this is 16 divided by minus 11 plus or minus the square root of the denominator, which is 25 here. This is exactly 16 divided by minus 11 plus or minus the square root of 25 is 5. Okay, from this we have 16 divided by minus 11 plus 5, or x equals 16 over minus 11 minus 5. So we have these two results here, okay? And what is this? So if we agree that x is exactly 16 divided by minus 11 plus 5, or x equals 16 divided by minus 11 minus 5. This is 16 divided by minus 6 Dividing both the top and bottom by 2 gives us minus 8 out of 3. Or x equals 16 divided by minus 16, which means x is minus 1. Right, obviously this confirms the correctness of the method because we saw before that indeed if we have 3x squared plus 11x plus 8 equals 0, we saw that indeed this implies that x is minus 8 out of 3 or x is minus 1. And therefore, the quadratic formula we've just proven works very well and is correct because it gives correct solutions to the quadratic equations. And we are done. And thanks everybody for your attention and time, and goodbye to you.